Good afternoon. The passion is the secret ingredient that drives hard work and excellence. Today is 31st episode of Creactive. Creactive is a group of people who are curious to gain the knowledge. Creactive. To be active, we need creativity. Creativity keeps us active is the meaning of Creactive, and tagline of Creactive is knowledge square. Sharing of knowledge increases the knowledge or doubles our knowledge is the tagline of Creactive. Creactive giving an opportunity to the resource person to present their knowledge, discoveries and opinions regarding their respective fields. So Creactive introducing resource persons who are masters in their fields. Creactive focusing on non-textual, non-academic, non-syllabus related topics. Every Saturday, we are organizing Creactive talks around 3 to 5 p.m. and also giving a live streaming of program through our YouTube channel. We have social medias where you can follow us for more updates. And today our topic is Indians Giant Leap to Mars, Orbiter Mission, MOM. To present this talk, we have Smt.Roopa M.V, Madam with us, and I welcome our speaker, Creactive volunteers and Creactive participants. To introduce today's speaker, we have Akshaya today. She is Creactive volunteer. So over to Akshaya.
A very warm and a graceful afternoon to everybody present in this session. I, Akshaya, feel immense pleasure to introduce the speaker of the day, Roopa Ma'am. I welcome you on behalf of the Creactive team. Ma'am perceives a profession of Deputy General Manager, Spacecraft Operations Group in ISRO Peenya, Bangalore. Ma'am has pursued her Bachelor's of Engineering in Electrical and Electronics Engineering at SJCE Mysuru and her Master's in Computer Science Engineering from SJCIT Chikbalapura. Ma'am has pioneered as the Deputy Project Director for various space explorations such as Chandrayana-3, OceanSat-3, the satellite series, SCAT-SAT, the satellite, Mars Orbiter Mission, MOM Mangalyana, Chandrayana-2, the lander and rover, OceanSat-2 satellite, Cartosat-3 satellite, and the list goes on. Ma'am has 20 plus years of mystical experience in spacecraft operation and health analysis. Cheers to you, ma'am, and many more to come. Besides her educational interests, ma'am is a profound sportswoman. She is a national level Kho player and a national level swimmer. She's been awarded with many awards for her diligent and spirited work. I take honor to list a few. The Astronautical Society of India ASI Space Gold Medal, TV9 Navanakshatragalu Award 2021, Distinctive Women Scientist Award 2017 from VTU Belgaum, International Women's Day Award from Delhi Commission, and etc. It is my gladness that we have such a versatile person along with us this afternoon. I welcome you once again, ma'am. I would also like to welcome Srinath sir, Supriya ma'am, and all the members of the Creactive team to this wondrous session and for making it happen. We are extremely grateful for your efforts in bringing about various talks every week and indeed boosting our knowledge. Lastly, I would like to welcome everyone present here. Over to Supriya ma'am.
Roopa ma'am, over to you.
Okay, thank you. Thank you, Supriya. Thank you, Akshaya, for your wonderful introduction or exaggerated introduction on me. Good afternoon to all. recreative. Good afternoon to all recreative participants. Really, recreative team is doing a wonderful work, introducing different fields in science and technology to every youth. So today, as decided, we will discuss on ISRO's most successful project, Mangalyaan, that is a Mars orbiter mission story, the project, how it went and how it has become successful. Okay, before coming, I'll just give my PPT. I'll just share the PPT.
Yes, ma'am.
PPT is...
Yes, ma'am.
Okay, thank you. So before coming to Mangalyaan, we'll just see ISRO has achieved the Mangalyaan with so many 40-50 years of experience. So how Indian space program has started, just a glimpse I'll give, and why Mars MOM mission has selected, and about the MOM spacecraft and its orbit insertion, its image, those things we'll just today we'll discuss.
Ma'am,
yeah,
annotation.
Okay. Yeah, 1 second. Yeah. It is stopping. But it is not going to that. 1 second. I just.
Ma'am, you stop streaming, stop sharing, and again you start, ma'am.
Yeah, that is better. Yeah, now it is visible.
Yes, ma'am.
Okay.
Just disable that annotation, ma'am.
Again,
more?
Yeah, it is in disable.
Okay.
Okay. Screen is visible, no? My PPT?
Yes, ma'am.
Okay. Yeah. I was just before just going to Mangalyaan project, I just want to tell about the ISRO, how ISRO has in India, ISRO has started. See, in the year 1957, when in October 4th, when suddenly surprising splashing news has come from Russia that Sputnik satellite has been launched. It is a surprise to the whole world. The US eye has become really red, and then on space race has started. Okay, that time we were just independent India. We were just seeing how nation, how to build the nation in science and technology. That time our founder of Indian space program, Mr. or Dr. Vikram Sarabhai, he was running his own physical research laboratory on the small unit he was running. He was doing experiments on ionosphere and magnetic equator. The experiments he was doing on his own with his team. See, there what we have to see is any opportunity, a small opportunity, how to encash that opportunity. See, you know the Earth equator. Earth equator is in the 0° latitude. It goes below the Earth, sorry, below the our India, and almost in the over Indonesia. Okay, there is one more equator called the magnetic equator. This magnetic equator, the magnetic North Pole and South Pole, is almost 11 degrees away from the your geographic North Pole, South Pole. So that equator is different from actual geographic equator. Okay, that magnetic equator is passing through our South India or Kerala region. So to further ionospheric study and magnetic waves study, they want this place where this magnetic equator is passing. See, it is passing over the other side of the globe is South America. But the advantage in India is the magnetic, the intensity of magnetic field is more, or it is more stronger compared to South America. So this he has encashed. So what he has done, he has invited all over the world, all his scientific friends from different countries to come and do the experiments in this area, because everybody was doing the experiment, but in that region they don't have this magnetic equator place. They have to search that place is required to do the experiment. It is so with his invitation, different nearly 4 or 5 countries scientists will agree and they'll come to India and do the experiments. But he will, with one condition, he will allow. That is, you do your experiments. That experiments is they have to launch a small sounding rockets. So in ionospheric around 10 kilometers to 80 kilometers it goes, and in situ experiment, while it is traveling, it will give the science data. Okay, and so the condition was you do your experiments, but you involve our Indian young scientists. So, okay, people will agree from other countries, from America, France, Canada, Japan. People will come, they'll do, but they'll involve our scientists during their experiments, because it is a sounding rocket. So the rocket technology we will start learning. So the Vikram Sarabhai has appointed some new scientists. In that, when he was searching new young scientists for this to learn the rocket technology, the one scientist he got as you know, the Abdul Kalam. So like that, different young scientists will come. They'll be learning the rocket technology. So in India, that is how the space era started. The space program has started. The first sounding rocket in India is Apache. Then now also, then onwards it is continuously they will be doing the sounding rocket experiments. But now also almost every Wednesday they are doing in the in that particular area. So how that area is selected is, since that magnetic equator is going around in the Kerala, in that a small village called Tumba. But see, you can see in the PPT one church is there. So in the Tumba is a very small village where there is no house. It is only a small hut. Only few fishermen were living. So when other country scientists will come and do the experiments in the Tumba village, they didn't had anything to stay there. So the only one building means there was one church, Magdalene Church was there. So Dr. Vikram Sarabhai went to church. The father he has talked, and finally those people have given the full church for the space program. So now also the church is there in our Trivandrum in the as a space museum. Okay. Like that, it started in 1969. Over this period, now ISRO is having nearly 22 centers all over India, doing both expert in rocket technology as well as spacecraft technology. We have different type of satellite presently in ISRO: communication satellite, remote sensing satellite, scientific satellite like AstroSat, Megatropics, navigation satellite. Then one we had a recovery satellite called SRE. It is a recovery capsule. Then a small satellite, nano satellite, deep space mission called Mangalyaan or Chandrayaan. Like the different satellite, we are become an expert in that field, and in the launch vehicle also. See, launch vehicle, once we have become a launch vehicle expert in launch vehicle, you need a satellite. So satellite, how the project started is the Vikram Sarabhai dream is for the farmers all over India. For the farmers, you need to tell something about the program for the farmers all over India at a time is through TV. So for the TV for the TV program, the satellite, mainly the satellite communication is required. With that dream, we started the satellite technology. So presently we have this many satellite types of satellites. In the types of satellite, this I'll come later. Okay. Satellite will have with a different orbit. We cannot launch the satellite in the same orbit. If it is a communication satellite, we'll go with the equatorial orbit. If it is a remote sensing, then we'll go with a polar satellite, like that. So once we become expertise in Earth viewing satellite, our interest has gone away from the Earth. What is there? So our next immediate neighbor interest is the moon. Okay. So we started our project with Chandrayaan 1. Chandrayaan 1 in 2008, 2009. So we have learned the technology, how to go instead of rotating around the Earth. Now we have to rotate around the moon and get the science in the moon surface. Once that also we achieved in the first attempt. So once we know the technology of the going to other than Earth, going away from the Earth and capturing the other planet or the moon. Next, see, even then the moon we are able to capture, but moon itself is within the sphere of influence of the Earth, that you know. Moon distances around 4 lakh kilometer or 3 lakh 84 kilometer. But Earth's sphere of influence is around 9.5 lakhs. So definitely the moon itself is within the sphere of influence of the Earth. So our next interest was how to go out of Earth sphere of influence and capture the other planet. So which planet to select? Definitely our interest will go the very neighbor planet, that is either we have to go towards Venus or the Mars. But why Mars? Why not Venus? Here you can see the Venus, Earth is our third planet. Venus is the second planet towards the sun. So it is very hot. It is near to the sun. Mars is away from sun. But that belt, I'll just show you. See, the planets, if you classify, there's 4 planets, we'll call it as a rocky planets. And the distance from sun to Earth and the moon, sorry, the Mars, around 150 million to 250 million, that belt is called a habitable zone. So Earth is, as of now, we know Earth is the only planet having the life. But since the Mars is there in the habitable zone, so our interest is whether any life is there in the Mars, whether our Earth, our human race, we can go there and save our species is also one interest. So definitely our interest will go to towards Mars, not towards the Venus. The other next is the giant planets, Jupiter and Saturn, that is called gaseous planets. Further away from the Saturn is ice giants. So like that it goes. So then some comparison, if you see, Earth is not right. You know, the season, Earth is having a seasonal variations. Why seasonal variation will come? Because Earth is tilted. Okay, so but Mars is also tilted. That I'll just come here. We can see here. Yeah, this is a picture. You can see how Earth is, because Earth is tilted 23.5 degree. We have a season. Same way, Mars is also tilted with a 25.9 degree. Hence, Mars is also having a seasonal variation, a seasonal effect. Okay, since Earth is near to Sun, its 1 year is 365 days. Mars 1 year is 687 or 686 days. And size-wise, anyhow, our Earth is bigger. 6,371 kilometer is a radius. Same way, if you take the Mars, it is around 3,400 kilometer. Like that, if you keep comparing, compared to Venus and Mars, similarities, if you see, Mars is more similar to Earth compared to the Venus. And Earth is having a 1 moon, and Mars is having a 2 moons called Phobos and Deimos. And the gravity wise, if you see, it is almost 38% of the Earth gravity the Mars is having. That means if you are weighing 100 kilo in Earth, there you will be weighing only 38 kgs. Okay. Then Earth is having almost 75% of nitrogen, and maximum in Mars is carbon dioxide, CO2. Okay, so like this, if this is the comparative study of Earth and the Mars. Then other one is since Mars is little away from the sun, only 44% of the sun illumination or the sun intensity compared to Earth. So it is a little cooler than the Earth. If Earth, this thing is temperature varies from -120 to say it is 80 degree. But here it goes up to -280, almost minus 140 degree centigrade it goes. So it is a bit cooler. So, so here these are all the things we had to take it into consideration for the design aspect. See, this is the MOM spacecraft. How MOM, see, once our interest has started to go to Mars, we have submitted our project to the government. Once we got the approval, it is not immediately you cannot launch. See, here in the orbit, you have seen, I'll just go back to that orbit. See here, Earth is also rotating around the sun. Mars is also rotating around the sun. But when we launch, what is the Earth position and what is the Mars position, you should know, and how many days it requires to go to from Earth to Mars. And by the time it goes to the Mars orbit, where is the Mars position, whether we will reach, and what is our launch vehicle capacity? Launch can give up to how many kilometers orbit, then how much we have to rise. All those things, if you compare, there is a definite window time for the launching. You cannot launch whenever satellite is ready or whenever we required. Okay, so once we got the project approval in 2011, then the very next opportunity was 2013 October November. 2013 October November is hardly 18 months, 1.5 years. 1.5 years is really short. But if we lose that window, opportunity window, then we had to wait for another 2 years. That is too long. So then immediately ISRO has taken a stand. Okay, we'll try for 2013 window to launch it. So in that way, we have started our project. So our the main objective was design and realization of the Mars orbiter mission and its earthbound maneuver, because the launcher cannot launch the satellite directly to the Martian orbit. So launcher also is having its own limitation. So we have to do some earthbound maneuvers to increase the our satellite orbit. Then it has to travel for 300 days, that cruise phase, how to manage. Then we have to insert our satellite into the Martian orbit, how to capture it. Then in the Martian orbit, what are all things we have to do? What is the Martian atmospheric model? According to that, the whole satellite has to be designed. Then another thing is the deep space communication we have to establish, because till now we know the communication in few lakhs kilometer only, that is only Chandrayaan. All other things was 36,000 or 800, 900 kilometer. Any communication what we are doing is RF communication that goes with the speed of light. So hundreds of kilometer, it goes in a fraction of second, you know, the speed of light. Even if it is a communication satellite where 36,000 kilometer height is there, it goes in seconds, few seconds. But if you go to Mars, that you have to communicate from 400 million. It varies from almost 85 million to 400 million kilometer. So whatever you are giving the command, it has to reach, it has to travel for 400 million kilometers, and it has to reach to satellite. And from there, the telemetry, whatever the satellite is giving transmitting the telemetry, to receive it has to travel for 400 million, and in the Earth, our antenna has to receive it. So that is called a deep space communication. So that also we need to, that is one technology objective, how to establish a deep space communication, the navigation. So when to launch? That time I told what is the Earth position, what is the Mars position, in what velocity both are going. When our orbit, once it is launched, the launch orbit, what is the launch orbit? Then the 300 days when it is traveling, what is that trajectory path of the spacecraft to travel? These are all the main objective of the technical objective. And once we go to the Martian surface, again we have to explore the Martian surface features and its mineralogy and the Martian atmosphere. Through scientific instrument, we should get the science out of it. So this is the objective. For that we started building the satellite. See, we can go with very high technology satellites, but the time is a big constraint. Within the available time of 18 months or 1.5 years, we cannot go. Say deep space communication with a higher frequency, we can do better. But higher frequency communicate that instruments, Even if you start purchase procedure itself is, it will take years. Then where to design itself will take years together. So, but you have only 18 months. So what we thought we'll do with the S-band frequency, where we were doing for the other, our earthbound satellite. But if it is a S-band, then our small antennas is not possible, which antenna we are using for earthbound satellite. Then we had to go with a very high gain antennas. So first time we started using high gain antenna. Then your solar panel, the same solar panel will not be sufficient to generate the power, because as I told, it is only 44%, intensity is only 44% of Earth intensity is available in the Mars. So your design small changes is required to power generation in the solar panel. Then fuel, lot of fuel is required, because the difference between the other satellite to deep space satellite is the fuel will not consume to go from Earth to the required orbit. If it is 800, all our IRS missions is around 500 to 700 kilometer height is there. So that vehicle itself will take the satellite to that required height, altitude, and it will eject. So we are not spending extra fuel to go to the orbit. We are using the fuel only to maintain in that orbit, like that. But here it is not so. 400 million, your vehicle cannot go and give the orbit satellite in that orbit. Satellite is giving only 28,000 kilometer height. Remaining, it has to go to the millions of kilometer, means we have to spend the fuel, whatever we are having in the satellite. So that is another challenging subsystem what we have seen. And the thermal design, thermal also. See, Earth atmosphere, if you see in the Martian atmosphere, it is totally a different, as I told, it is compared to Earth atmosphere, there the temperature, that is bit cooler. So accordingly, your thermal also has to be designed. And in the cruise space, when it is traveling for 300 kilometer, it will encounter a different temperature environment. For that also, our thermal system has to capable to maintain that thermal system. Then another one is called autonomy. See, any our earthbound satellite, as I told, communication is in the fraction of a second. If something happened to the satellite, we can monitor in real time and immediately we can react it. We can give a required command and make it all right. But in the Martian surface, it is not so, because when satellite is millions of kilometers, say 400 million away it is, communication now, if you calculate, if it goes in the speed of light, it takes nearly 22 minutes to reach one-way communication. Then once I give the command, it will reach. Whether command has reached or not, or whatever our intended work, it happened or not, to see another 22 minutes, we need to wait. So any real-time corrections in the spacecraft is not possible. So autonomy is a must. So that is another thing, a new thing, what challenge was there, because all the required autonomy was built in the satellite. So these are all only the required things we started designing. All others as it is, we are kept. So due to that, we had cost effective and we could do within the stipulated time. So as I told, next available window was 2013, October 20th to November 19th. Within that, you had to launch. Otherwise, you had to wait for another 2 years. This is what I was telling, all the things. So these are all the launch criteria. The launch window, I told you had 1.5, after 1.5 years, you had 15 days window. Within that, you had to launch. In that also, one particular day, if you select, then you have to see in that trajectory, any debris collision, any other satellite is coming in that path, or any other debris is in that path, which particular time you have to select. We waited, we delayed. See, we have selected for one particular time, then we delayed for 1 more minute after just 2-3 days before. That is to avoid collision of one particular debris. So these are all the criteria you have to see, and the weather condition. Rain is okay. If it is too much of windy, then we need to again change the time. And the rain safety when we are launching. After within 100 kilometers of the height it crossing, the land region should not be there. The rain safety also we should take into consideration. And vehicle health, how to monitor, where all the station, where all the antennas, ground antennas we have to establish to monitor the vehicle health as well as the satellite health. These are all the launch vehicle criteria we have to think and fix one particular launch date. This is our satellite criteria, which orbit it has to go. While launching, which earthbound one particular orbit it has to launch, then go to Mars, in what height it has to rotate, whether it has to rotate like Earth 500 circular orbit, whether it is possible, or with our available capacity, whether we can go to elliptical orbit, what is the orbit is required. These are all the criteria we have to, one has to think while designing the satellite and the launch. These are all the phases, as I told. Once the launch is fixed, pre-launch activity, one is satellite building, one place if it is happening in the ground station centers. The ground also we have to make it ready. All the where all the ground antenna should come, we have to establish. That I'll tell you how we establish shipborne terminal and available. If we don't have our own ground station, then we have to take station support from other space agencies. Then the launch activity, after the launch activity, earthbound orbit, then transfer orbit, the cruise phase of 300 days. These are all the different phases. Now we are in almost operational phase from past 8 years. This is the launching. The MOM mission was in the satellite cone. Just before launching, one photography I just wanted to show where the satellite is kept in the in the rocket, where the actual satellite is kept in the top tip, that cone. This is the cone is open, and where how the satellite is actually placed, you can see here. After this heat shield, this cone heat shield will be closed, and satellite will be in the top of the launch vehicle. This is the launch. Yeah, here you can see our India, Sriharikota, the satellite launching station, and this is the first launching trajectory path. In this satellite, when it launches, you can see on my mouse movement, it will start going in this path. So when it is going in this path, we should know the what are all the stations available in that path. 1 second. Yeah. See, you can see here we have a Sriharikota one. These are all one antennas where you can see all over the globe. I have marked. Bangalore, we have many antennas. We have both small antenna as well as a deep space antenna, that is 32-meter diameter antenna or 18-meter diameter antenna. Then after that, we have a Port Blair. In Port Blair, we have 2 antennas. Then next we have a Brunei, then Biak. Brunei, Biak, we have an antenna. Then coming further down, we didn't had any antenna. Then we have taken support from Canberra. That is JPL antenna is there in the Canberra. That station support we have taken. Then here, if it comes the other side of the globe, it has to travel over the Pacific Ocean. Here nothing is there, it is pure full ocean. Then it has to pass through this South America, where Brazilian some antennas were taken in the Cueva and Alcantara. Then further down here, we are taken from Hatibishak, that is South Africa. So these are all the places where we have taken the antenna support. Then what happened? See, satellite, before satellite is separated from the launch vehicle. Launch vehicle health very important, and especially when satellite is ejected from the launch vehicle, that instant telemetry is very crucial, because satellite is when launch is ejecting the satellite in particular orientation and particular velocity. If we know that in which direction and which velocity it is ejecting, then the other stations can track it. That will be knowing the satellite path, and it can track. Otherwise, if you don't know which direction satellite has got separated, in which velocity it got separated, it is very difficult to track the satellite, to track the satellite with the available antenna. So the ejecting place, when satellite is separating from the launch vehicle, that time telemetry is very important. But in the MOM case, all other satellite, it is happening over the land. It is near the Mauritius, where our own antenna is there. That antenna will track the both vehicle as well as the launch satellite. So we'll know that instant what is the orbit, the preliminary orbit information. Once we know, the further we'll predict and we'll start tracking it. But in the MOM, what happened is, it required a different trajectory. In that trajectory, vehicle separation, satellite separation from the vehicle was over the Pacific Ocean. There is no land, but communication is required, the telemetry is required. So some antenna is required there over the Pacific Ocean to get the information of the satellite separation. So we have kept 2 shipborne terminals, means we have hired 2 ships called Nalanda and Yamuna. We establish our antenna, small antenna over the ship. That 2 ships traveled from India for 1.5 months, and it went to near Fiji Island, near Pacific Ocean. We have installed and established the communication, and we tracked we got the telemetry from both the antennas. That is one really ground segment challenge it was. See, these are all the stations: Sriharikota, Port Blair, Brunei, Biak. As I told, ST is the shipboard terminal, 2 terminals. One is Nalanda and Yamuna, as I told, the ship names. These are all the antenna tracked for the launch vehicles. But for the further, once the satellite is separated, now all the antennas will start tracking the satellite. So for that, we have taken almost all over the globe, different antennas. That is called in the Brazil, Cueva and Alcantara. From South Africa, I told Hatibishak. Then Mauritius, 2 antenna, Bangalore, a few antennas. Out of 5, we have dedicated 2 antennas. And over Indonesia, in the Biak, 2 antennas, Brunei, 1 antenna. Madrid Goldstone Canberra is a JPL antenna. It is those are all the deep space antenna. Those we used, that is a deep space, means it's a huge antenna. It required when the satellite goes beyond 1 lakh kilometer. Before that, all these other satellite, antennas, that is around 10 to 11 meter antenna, can track when up to 1 lakh kilometer. And for the Port Blair, IDSN is our Indian deep space network. 2 antennas, one is 32 meter and another one is 18 meter. Now, see, you can just see how ground we have made it prepared for the Mom. See, mom launching immediately, it will go, we are getting the telemetry. It is easy, simple, very easy to say. But the ground system readiness, how many antennas all over the globe we have to make it ready, and every path you should know, you have to predict. Now presently satellite is going over which antenna, and next over which country, and next where it will go, that path also you should know, and that which velocity is going you should know, then only you can track the satellite. So this is a ground segment readiness. These are all the deep space antenna. It is a huge, even you can see our Bangalore is having a 32-meter deep space antenna, and it is having 18-meter antenna also. This shipborne terminal we had only for that launch plus a few days. Then we have taken it back. And for another 2-3 years, this JPL also was supporting in the Martian orbit. At present, we are having only our IDSN, our Bangalore Deep Space Network, that is 32-meter antenna is supporting throughout the mission. With a single antenna, we are able to track and do all the operations. So before going to other thing, you can just see one video about the MOM launch and its separation.
Mars orbital mission will be launched by the extended version of the Polar Satellite Launch Vehicle, known as the PSLV-XL, from Smt.Roopa, the spaceport of India. The rocket will lift off from the ground using its first stage solid rocket motor and strap-on boosters. As it travels through the atmosphere, the first stage and the strap-ons will burn out and separate from the vehicle, and the second stage, liquid engine, takes over. When the rocket comes out of the atmosphere, the tube shield, which protects the satellite from the atmosphere, will open out and drop down. Subsequently, the second stage will burn out and activate the third stage solid rocket motor. The third stage will again jettison from the rocket after completing its thrust phase. During the first 3 stages of the flight, ISTRAC down-range stations located at Bangalore, Smt.Roopa, Port Blair, Brunei, and Bayan will shoot the vehicle and continuously deliver the vehicle telemetry to the control center. Then enters a long coast phase of unclimbed trajectory for a duration of about 26 minutes. When the vehicle sets out of sight of the Bayan ground station, where it will not be visible to any ground station. Subsequently, it will be spotted and tracked by 2 shipboard terminals located in the Western Pacific Ocean, where the major entry events will be monitored. The first ship is located at such a position where it can monitor the ignition of the fourth stage liquid rocket engine. The location of the second ship is chosen so as to monitor the burnout of the fourth stage and satellite separation. Finally, the solar panels will deploy for generation and supply of solar power to spacecraft, followed by the deployment of the high-end antenna, which will support deep space communication. Initially, the spacecraft will be injected into an elliptical parking orbit of 250 kilometers at 23,500 kilometers. A series of orbit maneuvers will be conducted using the onboard liquid engine to raise the apogee altitudes. the spacecraft into a hyperbolic orbit, which escapes from the atmosphere of influence and embarks on a intercepting journey. The intercepting phase lasts for about 300 years, at the end of which the spacecraft reaches the sphere of influence of Mars. The Mars orbit insertion maneuver will be performed at the closest approach point over captured Mars in a 377 by 80,000 kilometer elliptical orbit.
Yeah. Here, what we can see is, you can just see when satellite launch time, where what I was explaining, no, the where the Earth is. Earth was here, the Mars was here. This is the blue is the Earth orbit, the pink is the Martian orbit, and the green is our mom path. Okay. November 30th was when it has left the Earth. Once we have done that, whatever you have seen in the video, we have done series of orbit maneuvers to rise the orbit. Then once it's attained the escape velocity, it has left the orbit on November 30th, 2013. That is almost 25 days. Launch was on 5th November. So this is the place. Then that time, this was a Mars place. Then when after 300 days of travel, by the time the mom satellite has come here, the Mars also has come here. The Earth was traveled, Earth position was here. This is the Earth position. Okay. That one. Here you can see the video I can just show you. This is the Earth orbit. Then the first circle was the launch orbit. Then the series of maneuver we did within 25 days by spending almost 250 kg of our fuel liquid engine using nearly 400 Newton thruster. It is a huge thruster. Then November 30th, it started traveling. It traveled for nearly 300 days, that is 298 days. So Earth is also moving, Mars is also moving, our mom also is coming, you can see. Then here it has entered the Martian sphere of influence. Then it, see here, it has gone back. So this is the first time. Other countries also have done that. America, Russia, and European Space Agency has already gone before 2013. But the capturing the Mars in this direction, it was the first time. But there also there was a challenge was there. See, here what when we allowed the Mars to go, then from behind we have captured it. There are some technical things we can discuss here. In further slides I'll tell you why we have gone in that way. Yeah. So this is the earthbound. First we started with 23,000 kilometer, then we have attained 28,000 kilometer, then we went up to 40,000 kilometer. Like that we started increasing. After 2 lakh kilometer, we could able to achieve the escape velocity of 11.2 kilometer per second. Then I traveled for 300 days. See, this is the present orbit. MOM orbit. Further that slide, I'll explain how we have captured it. Then this is the station, the deep space network in the Martian orbit. See why we want we cannot track only with one station is, see, like this. Earth is rotating. When this is the Mars planet, and our MOM is rotating around the Mars, so we can take it as a single point because of that distance. It is nearly 400 million kilometer away. Since Earth is rotating, this is our Bangalore antenna. This antenna, this antenna, when it moves here, the communication is happening only from here to here. When the other antennas, when it is away from the field of view of MOM, we cannot see. So by the time this goes, we need some other station to capture. That's why we have taken JPL 3 antennas called Canberra in Australia, Goldstone and Madrid in Spain. Okay, coming to the MOM different scientific instruments. MOM is having nearly 5 scientific instruments, mainly for atmospheric study. That is, one is a lab called Lyman alpha photometer. Lyman alpha photometer with a Lyman alpha narrow band. It will detect the deuterium and hydrogen. With that ratio, the main objective is to find the loss process of water. How whether earlier water was there and now water is not there, what is the process now all the water is evaporated. To see this instrument helps, that is called a LAP, Lyman alpha photometer. Then another one is called MSM, methane sensor for Mars. So this will detect the presence of methane in the atmosphere, Mars atmosphere. It works within the sphere range, that is a shortwave IR range. The long term, the methane, abundance of methane will give the information about the existence of life on the Mars surface. The other one is MENCA. MENCA is Martian Exosphere Composition Explorer. That is nothing but it has for the neutral composition of Martian atmosphere to study about the neutral compositions. And that will give in the day of Mars, what is the neural compositions and what is the seasonal variation. If you want to study, this is an in situ experiment about the upper atmosphere, exosphere. What is the neutral composition available? This instrument will give the information. Other one is our Mars color camera. It has given a beautiful images that will even it is required to study the Martian surface features, Martian dynamic process, the morphology in the near surface, and from the far the seasonal variation you can capture in the images. It is a color camera having at a 500 kilometer, its resolution is around 25 meter. At very far distance of 80,000 kilometer, the resolution will be around 4 kilometer resolution. With that, you can capture the whole Mars in a single snap. That is the beauty of this orbit and this camera. Other one is thermal imaging spectrometer. The thermal imaging spectrometer mainly to study the Martian underground hydrothermal system. It will give the to make the mineralogy mapping. This will help. These are all the science instrument that is having. See here what you can see. This is the Martian orbit. In this Martian orbit, when satellite is very near to Mars, this is the Mars. How we can take the picture. This is the picture when you are taken from 450 kilometer height. when we are in 70,000 kilometer, that is called the apoapsis region. In a single snap, we can cover the whole Martian surface. So seasonally, if you take, we can see the seasonal effect. This is the advantage of having the Mars color camera. Here, this image we have taken when in the cruise phase, when satellite was traveling from Earth to Mars. When this is also around 70,000 kilometer only. See, in the Martian surface, when 70,000 kilometer, the whole Mars we could able to capture. But this is from the 70,000 or 69,000 kilometer. We could able to capture the Indian region, and that time the cyclone, that cyclone name is in the November 2013, there was a cyclone. That cyclone you can able to see, you can able to capture. So this is from the Mars color camera. And other thing you can see is there is a huge wind. This wind in the Martian surface, capturing the wind in the Martian surface. And this is the Mars moon, that is Phobos, it is captured. So these are all the images, how the Mars color camera is helping to get the different signs out of it. That is previous one is Phobos and Deimos, and it is having a different lot of craters. So this crater mapping we could able to do, and that images we have made a map and we released to the public. Anybody can go to our site and see the Mars images. Then coming to operational challenges, there are a lot of operational challenges. Once we gone into the Martian surface, it is not that simply we started tracking and switching on the camera, collecting the data. It is not so. There are so many hurdles were there that we had to overcome. See, one is the comet siding spring was come very near. So first thing is we had to safeguard ourselves. Ourselves means our mom satellite itself we have to safeguard. Then we had to capture the comet. And then there is geometry called blackout and whiteout. During that time, how we have to spacecraft safeguard our satellite, I'll just tell you. Then there is a long eclipse. There is sometimes this natural satellite of Mars called Phobos and Deimos. One Phobos has come very near to the our mom satellite. So it is almost about to clash. That how to avoid like that. There are so many operational challenges was there. So this is this video you already seen how we have captured the Mars. Here you can see this is the mom path, that 300 days path. This here is the Mars. When it has come very near, we have captured the Mars in this path. Here, the sun is here, the earth is here. This was the mom path. So when we are capturing, we are gone behind the Mars planet. So there was no communication. Before that, see, so one sun is here and Mars planet is here. So there is an eclipse. There is no sunlight. So there is no power generation. That is first thing. Then the earth is here. So it is satellite is going behind the Mars. So there is no communication. We are not able to see whether satellite is able to capture or not. So see here on 24th September around 2 UT. 2 UT means morning 7:30 is the time it is supposed to capture. So but at that time, the whole satellite was behind the Mars. So we are not able to communicate with the satellite. The 20 minutes, the ISRO, the complete ISRO team was like holding a breath and saying for the 20 minutes whether satellite has really captured or it has escaped. Once if it is an escape, it is a one-time event. Further we cannot capture it, is it just fly off. So the criticality is the insertion should be that accurate. So it has come very near, almost 350 kilometer to the Martian surface. Then the upper side, upper means the farther side, it has gone up to 78. Our target was around 80,000 kilometer. So we could achieve up to 78,000 kilometer. So that is the orbit. It is traveling highly elliptical orbit. Next was, we captured, we went into Martian orbit on 24th September 2014. But within 25 days, less than 25 days, there was one comet called the Siding Spring comet was passing very near to the Mars planet. Yeah, it is going, what is the use, you can think. It is not so. See, the Siding Spring comet, the comet tail is having a lot of small particle shower. It is going with a very high velocity of 54 kilometers per second. So when it is traveling with that high velocity, even that tail small, it is like a ice particles, like a lot of sand. Suddenly, if it throws on your face, how the effect like that, the sand size small particles will travel with very high velocity. So if that hits our mom satellite, that is very dangerous. So first we have to safeguard our satellite. We have just entered the Martian surface on 24th September, but there was a comet coming. Then immediately what we have to do, we made the Mars planet itself as a shield. We went behind the Mars planet when it is passing. See, this is the comet path. This is the shower, you can see that shower when it is this orange was the our mom orbit. So the mom, we are gone behind the Mars when it is passing through. After it passes, then we have come out and we try to capture through our color camera. So that is one challenging event was there within 25 days. The other one is, say, the geometry. I told both our Earth is also rotating around the sun. The Mars is also rotating around the sun. Our mom is rotating around the Mars. But one point of a time, the Earth, Sun, and Mars will come in the straight line. With this geometry, what will happen? The communication blockage will happen. That's why we'll call it as a blackout. This sun corona, it is so strong. Whatever the command will give, that has to pass through this and come here. So along with our command, the sun noise will also travel. So sun noise is so heavy, so strong, we are not able to detect the command. So communication will not be there. And here from the mom, which is rotating around the Mars, that telemetry will be coming from the satellite to our antenna, but that also will block with this sun corona. So during that time, autonomy is a must. This happens, this geometry will happen every once in 2 years. So whenever this happens, nearly 50-52 days, we cannot command to the satellite. So the complete satellite will maintain with onboard autonomy. So the onboard autonomy, we have to tune in such a way, there is no communication. We are not giving any command. It has to do on its own all the activity. So this is one thing. In the same type, another way, see here, sun, Earth will come into center and Mars. This is also a straight line. So here also communication will not happen in one side. See, from whatever the command we are giving, the sun radiation, the sun noise and command will go together. So our satellite cannot receive the command, but whatever the satellite telemetry is there, that we are able to receive it. So telemetry, no issue, but we cannot communicate to the satellite from Earth. So there also communication is not possible. This also will happen once in 2 years. So this both geometry, onboard autonomy, we have to configure in such a way we are not communicate the satellite in the day-to-day for nearly 1.5 months. This is other challenge we faced and we are facing every alternate years. And another one is a long eclipse. See, our satellite is having a battery. Whenever eclipse is there, the battery has to support. Other time, our solar panel will support, you know. And so eclipse means our battery capacity is around 36 Ah capacity battery we are having, lithium ion battery. That can, if there are 100 minutes, there is no power generation from the satellite, means the eclipse, it is passing the eclipse. Also, our battery can sustain and keep the satellite in the good health. But if it is more than 100 minutes, then our battery capacity is not sufficient, then it is a problem. So that phenomena or that happened on 2017 January. See, you can see here, this is the duration around 50 minutes, 40 minutes, 30 minutes was there for last 3-4 years. In 2017 January, suddenly the eclipse duration has increased to 400 minutes, 500 minutes like that. So this is very difficult to manage. So what we have done, we have changed, we have done the big maneuver and changed the MOM orbit itself. See that it has totally avoided the eclipse and we could escape from that long eclipse scenario. But there is one more eclipse is coming. After that, again, all eclipse was within 100 minutes, 30-40 minutes like that, we could able to manage. But this year, 2022, April 1st, it is coming. Again, it is coming more than 450 minutes, means more than 7 hours eclipse is coming. So our battery capacity is not there. But that time there was a fuel was there. We could able to do the maneuver and try to escape. But now it is almost 8 years is over. So we don't have a fuel to do that big maneuver. So now this is a big challenge we have to face another 3 months. We are doing all the planning how we can escape without doing a maneuver. Okay, this is another challenge we are facing. Then this is other challenges. Satellite is designed in such a way at 500 kilometer or 300 up to 300 kilometer, it is okay. The satellite stability will be okay. Further, if it goes very near to the Martian surface, then the drag effect is more, then satellite stability we will lose the satellite stability. So that happened in 2018. The satellite has gone, means the periapsis height was coming to below 200. Whenever it is passing the periapsis in the inner orbit, satellite goes very near, means it was started disturbance, too much disturbance started. So controlling was very difficult. So what we did, again, we have done a big maneuver. We have fired the thrusters and raised this orbit. So more than 350 kilometer. So if we are not rising, it was almost coming below 50. Below 50 and all, we cannot control. It will go and hit the Mars surface. Then we will lose the satellite. So instead of that, we have done a maneuver and raised the orbit. So after that, we have predicted the orbit. See here, it is everything has gone beyond 400, 500 kilometer further. Now we are around 550 to 600 kilometer is the near, and anyhow far it is going nearly 72,000 kilometer. The other challenge was, I told there are two natural satellites are there for the Mars. One is Phobos and Deimos. This Phobos has come very near to our Mars. See, there was one critical alarm has come in last year, 2020, telling it is approaching, come to very near, just 46 kilometer, or it may hit also. See, we cannot change the Phobos orbit. What we have to do, we ourselves should go away from the Phobos, and we have to we should avoid this collision. So this is one big challenge we are facing every day. Today we are doing the orbit determination and seeing how far it is coming, Then that is one. After we have come out of its collision, then our interest was to take the image of the Phobos. See, this is the Phobos planet. It is not round like our moon. So Earth natural satellite moon is a very round. See, this is like a shapeless, like a alu only it is. So this we could able to capture. This is one thing we have done. And another interesting thing is, compared to other nations, our advantages, since our orbit is going nearly 70,000 kilometers, the Phobos orbit is only 6,000 kilometers. So we can capture the moon, that is Martian moon, from the behind the moons. That other country cannot do it, because their orbit is in such a way they can see only from the Martian surface towards the moons, Phobos and Deimos. But we can go behind and see, we can take the image. That is the beauty of our Indian mom orbit. See, when it is going this far, and Phobos and Deimos orbit is only here, so we can take the image from behind. So this is how the different challenges we are having. Presently, we are having this is orbit nearly 996 times. See, each orbit is around 66.5 hours is one full orbit. To have one full orbit, it takes around 66.5 hours orbit. It is I told around 530 kilometer. So 526 kilometer is near side. Far side, when it is going around 72,000 kilometer far. That elliptical orbit, it is rotating, and it is rotated almost 996 times. Now 8 years is completed. It is doing with a very good health. So what I just wanted to tell you. These are all the objective what we could complete. All the technological objective we have fulfilled. Fully we have met. Almost 37 kg fuel usable propellant was left when we entered into the Martian. We thought only 6 kg and only 6 months was our predicted life of the mom mission. But our operation was so accurate, and what we maintained is so accurate. Almost 37 kg fuel was left, and 8 years we could able to do all these all the hurdles I told, all the hurdles we could able to overcome with this available fuel. And now we are left out with only hardly 3.5 kg of fuel. Presently it is there. And another 3 months, I told, again one long eclipse is coming, that we have to see how we can overcome that hurdle. And deep space communication we could able to establish. Whatever the object we had before launch, all we could able to complete, all we could able to fulfill. That's why I told it is very successful project of the ISRO mission. So before that, we have different agencies having so many other missions there. This also, maybe you are interested. It is not only MOM is the not only satellite rotating around the Mars. There are so many other satellites rotating now. Recently, Perseverance, that is NASA's one satellite, has gone with a helicopter first time in the other outer atmosphere. Chinese is there, US thing is there, Europeans, ESA mission also is working operational. So then our MOM also is rotating very nicely from past 8 years. Thank you. How it was, you can tell, or if you have any doubt.
Yes.
Team. That's why it is hats off. Yeah.
Danvin is waiting to ask some questions, ma'am.
Yeah.
Actually, one by one, you can raise your hand so that I can unmute to ask questions. Danvin?
Ma'am?
Yeah, go ahead, Danvin.
Ma'am, there is the name like mom, no, ma'am. What is mom? What is the full form of it?
Mars Orbit Mission. Mars M Orbiter O Mission MOM.
Okay, ma'am.
Official name is that. Actually, we called Mangalyaan. Mangalyaan is what we thought, but when officially, when a project as a proposal is and got accepted, we got official name as Mars Orbiter Mission MOM.
Yes, ma'am. Ma'am, this mission. I hope this mission will continue forever.
Continue forever. See, that's what. Now we have only very few fuel. Only 3.5 kg fuel is a fuel also is required now to maintain. So we'll
Yes, ma'am.
how long we can maintain. We'll see. Okay, we'll try our level best.
But I thought you could send one rocket full of fuel enough for that mom.
Now, huh?
Yes, ma'am.
Okay.
You
Yeah.
could create it before it becomes less before 10 kg before it becomes like that.
See, no, the distance from Earth to Mars, I told it is 400 million. It takes nearly 10 months, almost 1 year to go. One thing. Other one is you should have a technology to take the fuel, put it in the mom. That technology also we should have, no? Then only we can do it. So that is a new technology we should build.
Yes, ma'am. Ma'am, are there any astronauts inside this mom?
No, ma. It is only unmanned mission.
Okay.
It is only a satellite. It is not a man. No human inside.
There is do you know the exact date of the rocket which will launch this year?
This year,
Yes, ma'am.
yeah, this year one satellite we are planning next month. That is for the earthbound satellite only, not for the Martian mission. Like a Mangalyaan 2 or to the Mars planet. Immediate this year we don't have. We are having in the future. This year we are having a project. Immediate is earthbound satellite only. The next month on 14th we are launching.
Okay, ma'am. Thank you.
Welcome.
Okay. Chinmay?
Ma'am, my question is about the deep space and the deep space network. Ma'am, can you please throw more light upon deep space network and deep space satellites?
Yes. Yeah. Deep space means, see, whatever deep into the space is nothing but instead of rotating around the earth, we are going away from the earth. Even Chandrayaan also, the moon mission also within the sphere of influence of the earth, the satellite in other planets, deep into the space. Yeah, we'll call it as a deep space network. For their communication is a challenge. See, for the mom itself, if you take example, it is the Mars planet will come very near, means almost 84 million kilometer to maximum of 384 or 400 million kilometer. It is in million kilometer. And you know, the communication happens in RF, radio frequency signal goes in the speed of light. Speed of light when it is traveling. The whatever the signal it carries, it has to travel for nearly 400 million kilometer and it should reach the satellite. The satellite should have that capacity to receive this particular signal. So if now this mom is communicating with the S-band frequency. So S-band, one particular frequency, it is 2298 gigahertz frequency. That frequency it should able to capture and detect the signal. Okay, that will be in the very minute. It is not even the milliwatt. It is 10 to the power of minus 12 watts. That fine signal strength it will be. So that is a challenge when it is traveling from such a huge distance. millions of kilometers with all other frequencies. You have to detect this particular frequency, capture that signal, then capture acquire the telemetry, convert it into engineering units is really a big challenge. So for that, you should have a very high gain antenna. Our